On my screen, I have the project page opened up for Drill Project 4. And this is the project that you guys are going to actually turn into me. You're going to turn in the canvas. So it's part of an assignment. On the project page, you can see an image of the drawing. You can also see videos from previous semesters where I have the recorded videos posted. We're going to follow the instructions given to us by the modeling, the Drill Project 4. And this video tonight will cover the modeling part of it. And we'll finish next class with the toolpath part of it. So modeling Drill Project 4, I'll go into Mastercam. I have a brand new session of Mastercam opened up. I like to maximize my graphics area, so I'll minimize any manager that might be visible. You can do that a couple different ways. So deselect it here. That'll close them out. Or you can just select the X at the top right corner of the manager. So I'm inside of Mastercam. First instruction from the project page says step 1. So first of all, let me read through this. It says using the drawing above, generate a 3-dimensional model using the Mastercam software. Step 1, use the rectangular shapes tool to create the outside profile of the part. If I go up to the drawing or the image of the drawing, the outside profile of the part is defined by this rectangle that measures 3 inches by 2 inches. We're instructed to use the rectangular shapes tool. So something that I want to point out. The notes here say origin is lower right corner of the part. So that would be this corner, this corner right here. And you'll also notice that most of the dimensions are referencing this edge and this edge, and where they intersect, we have this corner. So I'm going to draw in a rectangular shape, measures 3 inches by 2 inches. The anchor point will be at the lower right corner, and then I'll place that anchor point at the origin of Mastercam. Back inside of Mastercam, I'll go to wireframe. Under rectangle, you'll find rectangular shapes. I'm going to set the origin to the bottom right corner. The width will be 3 inches, and then the height will be 2 inches. Let me double check those numbers. So 3 by 2. Once you hit enter, after entering the height, you move your cursor into the graphics area. You'll see a preview of that rectangular shape attached to your cursor. Mastercam is asking us to select the base point. I'll let my cursor lock onto the origin. Once you see it lock into position, left click. Once I place it, I'll select OK to exit the tool. I now have the rectangular shape attached to my origin. I'm going to check the position and size of it real quick. If I go to the Home tab, and in the Analyze section, if I expand Dynamic, you'll find Position. I'm going to select the corner that's opposite of the origin. So I let my cursor lock on to this upper left corner. It's telling me that that point is, or that point is located at -3 in the X, +2 in the Y. And that's just a way for me to double check the placement and the size of the initial shape that we're creating. So from here, I'll select OK. That completes step 1. If I go back to the project page, step 2, use the point position tool to create one point at the center of the hole closest to the origin. So the origin is at the lower right corner. The hole that's closest to the origin would be this one. The X coordinate is defined by this dimension. What is the X coordinate relative to the origin? What's the X value?
-625.
-0.625, correct. And what is the Y coordinate relative to the origin?
0.5.
Correct. So we're going to enter in a value of -0.625 for the X and then 0.5 for the Y. Go back in the Mastercam. Go to the wireframe tab. For the point position, or select the points, or go to the point section and select point position. It says create point position. In this case, I'm going to hit the space bar. And you can enter this value in a couple of different ways. I'm going to type in X negative 0.625, Y 0.5, and then hit enter. And you'll see a point appear at that XY location relative to the origin. From here, I'll select OK to exit the tool. Let's go back to the project page. Step 3. Use the circle center point tool to create a circle centered at the point created by step 2. What's the diameter of the circle that we're going to create? It's going to be equal to the diameter of the hole that's going all the way through the part. I could create, make it the same size as the countersink. Could do it either, one of two ways. I'm actually going to create it equal to the diameter of the countersink. The countersink is 0.45. So let's do this. Go to wireframe, circle center point. In the diameter value, in the diameter field, type in 0.45, hit enter, and then position your cursor into the graphics area. I'll let my cursor lock onto the point and then left click. This will be the only circle that we create using this tool. So at this time, I'll select OK to exit the tool. I'll go back to the project page. Step 4, use the translate tool to create the additional instances of the circle and point. Along the x-axis, I have 2 additional instances, and it looks like the spacing between them is going to be 0.875. Yeah, so 1.5 minus 0.65 is 0.875. And then 2.375 minus 1.5, once again, that's 0.875. So the spacing between the columns, 0.875, and then the spacing in the X will be the difference between 1.5 and 5, which is 1. So let's do this. We're going to use the transform tool. I'll go to transform, translate. It says select entities to translate. You could pick select the point in the circle. You could window select them, or you could come up to the selection filters and select all point entities and all circle entities. Once they're selected, select end selection. Let's start by creating the additional instances along the x-axis. For the delta x, set that to 0.875 and hit enter. We'll need 2 additional copies. So in the instances field, type in 2. And then for the direction, I'll come down to direction at the very bottom and I'll select opposite side. You could have typed in negative 0.875 and it would have sent it in the correct direction. So I've got my 2 additional copies along the x-axis. From here, I'll select OK, create new operation. It's now asking me to select the next set of entities to translate. This time I'll select all group entities, select all result entities. Once you're done selecting, select end selection. For the delta X, set this to 0 now. And then for the Y, type in 1. Now, because it's holding on to settings from the previous transform, go back down to direction. This time, change it to define side. We'll also need to reduce the number of copies. So where it says instances, set this to 1. From here, I'll select OK. To clear the temporarily assigned colors, I could go to the Home tab In the attributes section, I can select clear colors, or I can right click on my screen and select clear colors. We'll go back to the project page. Step 5, create the standard levels that we'll be using for this class. We'll go back in the Mastercam. I'm going to make the level manager visible. I'll go to View. In the Manager section, I'll select Levels. Create the default levels. You can reference this image on the project page. So level 1, we'll call this solid support geometry. To create a second level, select the green plus sign. Double click in the name field. We'll call this solid model. Create a third level, select the green plus sign. Double click in the name field. We'll call this wireframe from solid. Create a fourth level. We'll call this dimensions. The fifth level we'll call points. The sixth level we'll call material. And the seventh level we'll call name. That completes step 5. So once you get the level manager created with all the correct levels, we're going to move on to step 6. It says use the Smart Dimension tool to dimension the two-dimensional representation of the part. Now, something that we haven't done yet, but I'm not going to wait till I get to step 12. I highly recommend that you save your work prior to getting to step 12. I'll go to File, Save. I'm going to save it in my class folder. So I'll go to my class folder, MACT 160 Fall. This is Drill Project 4. I'm going to create a dedicated folder to this project. So in the class folder, create a new folder. We'll call this Drill Project 4. 1 second. So I'm going to create a folder dedicated to this project. So I already created the folder, but I need to rename it. So rename, we'll call this Drill Project 4. Everything associated with this project is going to go in this folder. So I'll open up Drill Project 4, and I'm going to save the Mastercam file with the same name. So Drill Project 4. And then I'll select Save. And then once I save it, if you look at the top of your screen, you can see the path to where it's saved to. So and in this case, you can see it's in my class folder. It's got its own working folder, and the Mastercam file is called Drill Project 4. This is how I want you guys to save all of your work. From here, we'll go back to the project page. We're going to use Smart Dimension tool to dimension the 2D representation of the part. What I try to do is I try to match the dimensions that I see on the blueprint. That way I'm less likely to miss something. Doesn't need to be perfect. I'm just getting it close. The numbers need to be exact, but the way you go about it, the way it appears when you dimension it, just get it close. So from here, I'll go back to Mastercam. I'll go to the Home tab. I'm going to set my wireframe color to red. I want to be able to tell the difference between the wireframe geometry or the solid support geometry and the dimensions. So I'm changing the wireframe geometry to red. I'm making the dimensions level the active level. Anything we create takes on the active color and gets placed on the active level. I'll go to the drafting tab. I'll use the Smart Dimension tool. I'll start by creating these four horizontal dimensions. I select this edge, the center of this hole, and then I'll pull the dimension off of the part to place it. Now, while you're placing this first dimension, you can change the height of the text. So if I come over here, while it's still active, I select height. I can change this to 0.125, make it a little bit smaller. Select OK. And now I can place the dimension. It's a little bit easier to place it this way. Here I'll select the the vertical line again. I'll select the center of this circle. I can flip the arrow to the inside with the A key. And then I'll move on, I'll create the next set of dimensions. For the overall length, I'm just selecting the top edge. So those are the four horizontal dimensions that I need. I also need three vertical dimensions, and then this diameter dimension. So I can select this edge for the overall height, 2. Then I'll select this edge, the center of this circle. I'll select this edge and then the center of this circle. That one's lost its associativity. So what I could do is I can delete it or try and do it again. Let me delete that one. Select this edge, the center. That's a little bit better. Also need a diameter dimension. Now, if I select this circle at around the 10 o'clock position, be careful, don't lock on to quadrants. I'm just approaching it from, say, the 10 o'clock, and once I see it highlight, left click. I'll drag the dimension off of the part. If I hit the A key while the dimension is active, you can flip the arrows to the inside or the outside. I prefer them on the outside, so from here, I'll left click on the screen to place the dimension. And if I go back to the blueprint, I believe that's everything that I can dimension from the top view. So that's good. I'll exit the drafting tool. I can fit the screen. And what I would do is I would double check these numbers to the blueprint. And I'm seeing everything is lining up or matching up. So I like what I see. Once you verify that the part is correct or the 2D representation of the part is correct, make the solid model level the active level and then make the dimensions level invisible. And this would be a good time for us to save our work again.
Oh, Professor?
Yes, sir.
So isn't 0.37 the circle diameter we want for extruding out, because it looks like the countersink is the 0.45.
Yeah, it's one or the other would work. You just need to be aware of what you're doing.
Okay.
What's going to happen is I'm going to come back in and use the hole tool that's under the solids tab, and that's going to control the countersink and the diameter of the hole that's going through the part.
Mm-hmm.
And then I'm going to create a level, or I'm going to create a wireframe representation based off of the solid model that will have both of those diameters included in it. For the time being, I'm just using this for I'm going to use the geometry that's currently on my screen to create the solid model. Does that make sense?
Yeah, but you can do it with 0.397 as an extrude, right? Because extrude doesn't.
You could do it either way. I'm going to do it a slightly different way. The way I'm doing it's going to include the countersink and the through hole in one item.
Got it. Okay.
All right.
All right. Yep. Just curious.
When it's all said and done, if the model's correct, I'm not going to say one way is better than the other. This is just a method that that's kind of evolved over doing this for a few years. And I find this way to be, for me, it works best. I tend to be a little bit more thorough when I do it this way. All right.
Got
it. Okay, cool.
Thanks.
All right. So from here, we've got our dimensions created. We made the solid model level active. Let's look at the instructions again. So use the extrude tool to create a solid model of the part. And I should say, create the solid representation of the base feature. It's just going to be a rectangular shape that measures 1 inch thick. And that's coming from this dimension right here. And then we're going to use the hole tool that resides underneath the solids tool to create the countersunk hole. So 7 and 8, we're using what's referred to as solids tools. So let's start by extruding the outside profile of the part 1 inch in the negative Z. Before we do that, let's change the solid color to something that we haven't used yet. I'm going to change it to this blue color right here. So any solid that we create is going to take on this color, and it's going to be placed on the solid model level. That's the active level. When I'm giving thickness or depth to a part, I like to look at it from an isometric view. That way I can see what's happening along the Z-axis. So in this case, if I right click on my screen and look at it from an isometric view, you can now see the Z-axis. Before we were looking down the Z-axis, we were looking perpendicular to the XY plane. Once we look at it from an isometric view, we can see all 3 axes. Let's extrude the outside profile 1 inch in the negative Z. I want to keep the coordinate system and the solid support geometry on the top of the part. So I'll go to solids, extrude. The wireframe chaining dialog box appears. The mode is set to wireframe. I'll change back to C plane. And the selection method, I'll select chain. Once you do that, select one of the items that represents the outside profile of the part. And when you do that, all connected entities should become selected. Once you select the chain, select OK. I'm seeing a preview of the extrusion. The default value is going to extrude in the positive Z for a distance of 1 inch. I can flip the direction with this icon, reverse all. And the default distance works in this case, so I'm not going to change that. From here, I'll select OK. I'll save my work. We'll go on to step 7, or step 8, I should say. Use the hole tool to create the countersunk holes in the part. If I go up to the blueprint again, you can see that the diameter of the hole that goes all the way through the part is 0.397. And then the diameter of the countersink is 0.45. We're going to use that information to define the countersunk hole. So we'll go to the solids tab, hole. It says use panel to modify hole settings. So what we can do, let's start by selecting where we want the holes to be placed. In this field where it says position, select this icon, add position. Returns you to the graphics window and to add new hole positions by selecting points or circles. So when you select a circle, it knows to place the hole at the center of the circle. So I'll select this icon. Now, if I select this circle, you won't be able to see it, or it'll be difficult to see. It's going to place a white point at the center. And when I do that, because my points are visible, kind of difficult to see. But I'm going to work my way around and select all 6 circles. And then once I'm done, it says press enter. And as soon as you press enter, you see a preview of the 6 holes in the part. Now, what's going on here is the default values are currently active. What we need to do is we need to change the hole style and a few of the diameter values. So for the hole style, expand the type menu and select countersink. For the diameter, this is the diameter of the hole. You could type in 0.397, or if you know that 0.397 happens to be a letter X drill, you could type in pound X and hit enter. For the countersink diameter, I believe it's 0.425. Let's double check that. So 0.45, my bad. So the countersink diameter is 0.45, hit enter. Now, if I zoom in, you can see that the circles that we drew in earlier match the outside diameter of the countersink. The countersink angle. Let's go back to the blueprint.
90.
What's the 90? Correct. And that information is given to us by this right here. So countersink, 450 thousandths in diameter by 90 degrees. So in the countersink angle, set this to 90. Very hard to see the difference between the two. So you got to really check the values. So 0.397 by 0.45 countersink, and it's got a countersink angle at 90 degrees. We can also control the angle of the drill tip, but if the hole's going all the way through, we don't need to have that shown, or it's not going to show up on the model. So where it says depth, set it to through all. And that should take care of everything for the holes. Just tumbling the model, making sure that everything looks good. The holes do go all the way through. So from here, I'll select OK. I can look at it from an isometric view. I can fit my screen. I can unzoom 80%. And I'll save my work. Something that I just realized as I was selecting the circles, I didn't place the points on the correct level. Let's do that right now. I want to place all 6 points on level 5. A way for me to do that is I can first select the points. If I go to this icon, select all point entities. While they're selected, I can right click on my screen, change level. Now, because I already selected them, it's not asking me to select entities to change the level of. For the operation, let's select move. I'm moving them to level 5, so it's not the active level. So deselect active level. And then in the number field, type in 5 and hit OK. And you can now see 6 entities have been moved to level 5. If I make that level invisible, they're no longer there. They're still there, but they're no longer visible. So they're on the correct level. From here, I'll go back to the project page. Let's see here. Step 9, use the curve all edges tool to create the wireframe representation of the part. Let's change the wireframe color so we can differentiate between the solid support geometry and the wireframe from solid. If I go back to the Home tab, under wireframe color, I'm going to select this gold color right here. I'm also going to turn off the solid support geometry level. The only thing that should be visible on my screen right now is the one solid model that we have. A way that we can check that, if you go to the Home tab and you go to Analyze Statistics, it's going to show you everything that's currently visible on my screen. And in this case, I only have the one solid model. That's what I'm checking for. If I had all my solid support geometry visible on my screen, then I go to Statistics, 4 lines, 6 arcs, 1 solid. So make the solid support geometry level invisible. Make the wireframe from solid level visible. I've got my wireframe color set to this gold color. I'll go to wireframe. We're looking for curve all edges. Now I'm using a slightly different version of the software than you guys are. In this case, I'm going to triple click on the solid body. And if I do it correctly, the whole part becomes selected, and I'm struggling with this. Not bounding box, curve all edges. There we go. Once the entire part becomes selected, we want all surfaces highlighted. I'll select end selection. You can see all the edges of the part become highlighted, or they appear to be highlighted. And what's happening is Mastercam is creating wireframe geometry on all edges of all edges of the part. So from here, I'll select OK. And I'll have 30 entities on level 3. Look at it from an isometric view. Save my work. We'll go back to the project page. Step 10, use the bounding box tool to create the solid representation of the material. So basically, this is going to be the part before it has any holes drilled in it. We're going to create a solid model of it using the bounding box tool. Back inside of Mastercam, go to the Home tab. Once again, we want to change up the color of the solid model. And I'm going to change it to, can't remember which color I used last time. This rust color right here, maybe, or this burgundy color. I will provide you guys with a standard for colors with the following projects, but for now, I just try to use different colors. Don't use the same colors for the geometry. Actually, I'm going to change that up again. I'm going to select this color right. It's too close to the original. Use this purple color here. Material level, make the material level the active level. Go to wireframe, bounding box. To select everything on my screen, I'll select Control A. I'll select End Selection. You can see that Mastercam, if you look at the size of the bounding box, you can see that Mastercam is creating an envelope around all selected entities. So 3 by 2 by 1. Those dimensions or those numbers should match the overall dimensions of the part. Once you verify that is correct, scroll down where it says create geometry, deselect lines and arcs and select solids. From here, I'll select OK. You can see the solid representation of the material overlaying our part. From here, I'll make the name level the active level, and I'll make the material level invisible. And once again, I'll save my work. How's everyone doing?
Good.
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 Nice. Perfect. All right, so from here, we're going to go to the project page. We're on to step 11. Use the create letters tool to create your first and last initial on the top of the part. Reference drawing for size of text and location. So if I scroll up here, it says engrave first and last initial here. Use 0.25 tall box font. So we don't need to be perfect, or we don't have to place it perfectly. We're just going to get it close. The height will be 0.25 box font. Make the name level active. And let's change the wireframe color again. Let's change it to something that's easily seen with the current color of the part. I'm thinking I'm going to change it to this red color, this burgundy color. Let's see how that works. So I changed the wireframe color and I made the name level the active level. I'm going to set my construction plane to 2D. Wherever I place this 2D geometry, I need to have it sitting on this top face. So if I set this to 2D and I look at it from a top view, it doesn't matter where I place it along the XY plane. It's going to be placed planar to Z0, or it's going to be placed at Z0, and it should be planar with the XY plane. So I've changed over to a 2D construction plane. I'm looking at it from a top view. I'll go to wireframe, create letters. For the style, expand this menu, and we're going to use Mastercam box font. For the letters, type in your first and last initial. For the height, type in 0.25, hit enter. And then once you hit enter, if you move your cursor into the graphics area, you should see your initials attached to your cursor. And I'm just going to place them right about here. Be careful, your cursor wants to lock onto things because we do have our auto cursor active. So get it close to where it needs to be, and then left click to place it. If it looks good, you can hit the green check to exit the tool. And if you look at it from an isometric view, it should be sitting on the top of the part. So from here, I'll look at it from an isometric view, hit the screen, unzoom, and then I'll save my work. If I go back to the project page and I look at the instructions for modeling drill project 4, we just completed step 11 and we saved our work one last time. So this will be a good point for us to stop at. Next video or next class, we'll move forward and we'll do the creating of the tool paths. And we should be able to complete this project by the end of next class or our next meeting. So I'm going to stop the video here, and that'll complete what we're going to go over for tonight.